Aloha. I was on vacation in Hawaii until last Saturday. I was there for 2 weeks, and I still feel like I am in Hawaii. So I decided to bring the Hawaii vibes to you guys. So this behind me is one of the Maui's beach. I shot this video here in Lahaina, and I still have my Hawaiian shirt. I'm going to talk about SSIS. It's a very professional setting, but I decided to bring some Hawaiian vibes to you guys. So aloha. Okay, let's get the slide deck going here. Let me see if this one is there. Perfect. And let me get this guy here. There we go. All right, so Jean, once again, thank you for having me with the group. I still hold the honor to be the very first presenter on the very first session that you put up there a couple of years ago, right? For the Cloud DBA. It's great to be back here all the time. And for us, for the group, my name is Armando Lacerda. Like Jean already mentioned, I'm a Microsoft MVP. I I'm an MVP is an award that Microsoft gives to professionals like you and me when we present and when we share our knowledge about Microsoft technologies, blog posts and videos and sessions like this and conferences. So you can become an MVP if you want to just get out there, share what you know about Microsoft technology and some open source technology too. Microsoft also runs a lot of open source technologies like Kubernetes, for instance, and you can become an MVP on Windows Azure with Kubernetes support. So there are multiple categories. My particular one is in data and AI. I am an independent contractor, independent consultant. I work as a data architect and a data engineer. I've been a Microsoft SQL Server DBA since SQL Server 6.5. I was there on the former DTS, right? Was the grandfather of SSIS. I should say father, just one generation behind. So the father of the parent of SSSIS, and before we get the cloud, before we moved our workloads, and I moved my career to focus into the cloud technologies. I was, a full-time SQL developer and BI data warehouse developer using Microsoft Tech on-premise. It was about 2010 is when is my landmark when I developed my first web application using SQL Server in Azure. And 2014, 2015 is when the market started changing for me, when I started getting a lot of more workloads and projects running in Azure, hybrid fashion, and then always Azure. The project I'm working on today, it's moving something that was in SQL Server on-premise that moved to SQL Managed Instance in the cloud, kind of a lift and shift. And now we are moving into a serverless platform fully in Azure using all the serverless aspects of SQL and other computing capacities. So that's a little bit about me. MVP, some experience on SQL Server and Azure. I'm also Microsoft MCT, which means I'm a certified trainer. I do a lot of class deliveries for Microsoft customers using Microsoft official content, and I hold a few certifications in the past. Microsoft used to send you those certificates, right? Like previous generation that I belong to. I used to get those certificates. A few years ago, Microsoft decided to start sending the certificates. They still send if you want to, but now they give you badges like this, and those badges show your certifications. So if you want to keep the conversation going after this session is over, you can go ahead and connect with me on LinkedIn. That's the only social network that I use for professional communication. I canceled my Twitter account last month. And Facebook, I'm also there, but if you want to see my pictures from Hawaii, I'll be there. And you'll find out that my hair is originally black, but when I went to Hawaii, somehow it got blonde. Go figure. Anyways, things that happens when you go to Hawaii. All right, what are we going to talking about here today? What is our agenda? Um, our agenda will, my goal here is, let me step back a little bit and tell you why I put this session together, this particular session together last year. I was working with this company, running this project, and we had a lot of SSIS packages, and we want to scale up the company's capacity of processing data, and they want to move into the cloud, and we are going to get those SSIS packages in cloud technology, particularly in Synapse and transformation pipelines. The company's team was, well versed in SSIS, but they're like, how do I do this in the cloud? Things seem so different. How do we change this? What's changed? What should I learn? And I put this session together to kind of a bridge and show to that team that the transformation aspects and the way to work in a cloud is very similar to SSIS packages. There are a lot of differences, of course, and a bunch of extra elements for expanding capacity, expanding processing, but the basic elements are there. So the goal of this session is understanding why we don't get those SSIS packages and just run them in the cloud, which is an option, by the way. We're going to show you in a few. Which is an option, but why we want to do what is called a re-architecture or a re-implementation of the solution. We don't want to do a lift and shift, like get what is on premise and give it to the cloud. We don't want to do that. We want to benefit from the cloud scalability, so we want to do a re-architect and re-implementation of what is already there. Some people look at this approach and they're like, it's crazy. If something is working, don't mess with it, right? Don't break it. Well, it is working, but it's not scalable. So we need something new. That's why we change cars from time to time, right? So it's kind of the same idea here. So our agenda is to understand why we need to switch cars, right? Why we need to move away from SSIS and get into something new. And after we understand that, we're gonna do a brief review just to make sure we are on the same page. When we talk about names, sometimes nomenclatures they get in a way, right? We try to communicate something. We call things different names. So we're gonna make sure they're going to the skeleton, and we see what is in there and kind of a map to what is in integration service. Doing the bridge. Kind of mapping what is integration service and what is in the cloud in Synapse. And the idea of the workshop here is, like I said, for that session, we had some hands-on going on. We're here not going to have hands-on for you guys because we don't have that much time, and our interaction here is kind of different. But I will be mixing up these two guys here together by doing demos as we go along, as we're going to do demos. And by the way, like Gian mentioned, if you guys have questions as we move along, you can go ahead and write on the chat window. I have the chat window here now on the monitor, so try to keep an eye on the chat window there as we move along. If you have a question, you can also raise your hand, your digital hand, right, using Teams feature. I'll try to keep an eye here. If I see a question, I will stop and work with you with your question. All right, so let's get to it. Workshop. There we go. So SSIS, if you look into the time that SSIS was to DTS, and it was a different approach back then. It was just VB scripting. You could do some scriptings in there, but using VBS language, and some of the things were visual. But then came .NET framework, and the things got better and upgraded from DTS to SSIS. But if you count both together, ignoring the platform change, we still have, right, still there. So we have 22 years of very stable technology and expansible, sorry, we can expand it, right? Expandable technology, that's the right word, sorry. Expandable technology to do data processing on premise, and it works fine, it's stable, it's great. So why do we need to move away from it? And that kind of reminds me of a story. I was in Redmond for a small conference, trainers conference, and there was SQL Server 2012 back then that was going to be released, I believe, so about 10 years ago. And there were some new features coming out, and Microsoft was already doing the move to the cloud. So Azure back then was like Windows Azure. There was a code name before that one, and it was already coming out. There were some things already being made available publicly on the public Azure offering. SQL Server was already there. And I remember one of the folks I was talking to from Microsoft, they were product managers down there at Microsoft. They're like, yeah, we're thinking about creating these features for SSIS back in 2012 in SSIS and expanded this way and that way. And then came the order all the way from director level, say, what you do is for on-premise only, and what you're gonna do from now on is cloud first. It has to work in the cloud first and then on-premise. Everything. So back then, from about 10 years ago, Microsoft was already like that, right? Was thinking about what can be delivered in the cloud in a scalable way, and then move the way to on-premise. It is still like that too today. And when you talk SQL Server, most of the things in SQL Server first come in the cloud. Most of the innovations first come in the cloud, and then you see it coming to on-premise later. There are very few exceptions to that, like that SQL Server Enclave came on-premise first due to hardware restriction, and then was made available in the cloud. But most of the things first come in the cloud. So why not stay in integration service? One of the reasons is most of the data sources and most of the data innovations, most of the transformations and AI approach and things like that, we will see them popping up first in the cloud, and perhaps they will make their way to on-premise. It may take a few months, it may take half a year, perhaps even more than a year. But all the innovations, all the new things you need to implement for new projects, you will see those things first in the cloud. You won't see those things for a while in on-premise platforms. Besides that new gadgets that we get by working in a cloud platform, cloud first, we also have a very specific, important element on SSIS, which is about the scalability of how much data we can process using SSIS. So let me get this thing here a little bigger. Let me see if I can do this. Yeah, I got it here smaller here, so there you can read it better. So when we are working with SSIS comes with SQL Server. So we install SSIS in a box with SQL Server. Usually you have a deployment like that, where you have SQL Server and SSIS running on the same box. Most production environments will have those two guys running in distinct boxes, right? You have your SSIS running on a dedicated virtual machine where it will not be disturbed by other workloads on the same VM, even though the VM could be on a hardware that have some other virtual machines running there, but that's something else. So SSIS can work with by itself, right, on a VM, but it usually works better if the target is on the same box, if the SQL Server it's writing to is in the same box. If the target where the data is moving to is not SQL Server, it's like a file share or some other place, then it can run standalone, no big deal. But here's the point. Don't miss the point. Where's my... I think I have a pointer here. I'm not sure if this guy is gonna work. Let's see. Nah, it's not gonna work. So let me use my mouse. Mouse here. There we go. There we go. So what's the point here? I don't want you to miss. Integration service, SQL Server integration service, can be installed and can run on one VM, one virtual machine. If you need more processing power, you can scale up. So you can get your virtual machine and add more memory, add more vCores or vCPUs or CPUs, whatever your virtualization technology calls it. So you can add more CPUs on that VM, but here's the point, you can only scale up. You cannot scale out, meaning you want to have the workload running in multiple VMs in parallel. You cannot scale out. SSIS does not support that. So if we, where's my mouse? Is the mouse still there? Yeah. So we can have multiple SQL servers as a source. We can write to a particular SQL Server destination, and we can have a SQL Server to monitor the SSIS behavior. So like I said, we can have this thing here on a VM. I'm not even going to try my pen. We can have this thing here running on a VM and having the SSIS DB database in a SQL instance to monitor the package's execution and all of that. And we can still have multiple SQL Server sources or multiple sources, not even SQL Server, but other sources. But the compute is always one. I'm not sure if you have noticed before, but when you install SSIS, when you install SQL Server and install SSIS, there is an option to do SSIS scale out. And when you do SSIS scale out, the idea is to send packages to run on other SQL servers outside where in other SSIS, I'd rather say installations and running other VMs besides the one that is there. But the issue with that one, with that particular approach, is you are running distinct packages. You can even run the same package, copies of the same packages in multiple VMs, but they must tap into distinct sources. They cannot share the same source and coordinate data distribution among all the SSIS servers involved. So the bottom line, SSIS is a service in SQL Server that does not scale out. It does have an option for scaling out that, again, is to distribute packages execution from distinct sources. But if this particular source here, let's say this source here is 100 terabytes, you will not have one SSIS, multiple SSIS tap into the same 100 terabytes and splitting up that 100 terabytes among multiple servers. SSIS does not support that. And that's why we want to move into the cloud when we have that massive amount of data to process, and we need cloud scalability. So why not to stay in SSIS? Short answer, it's not as scalable as the data has been growing over the years, right? I've worked with projects, and one of the projects I worked a couple of years ago, we moved petabytes, a couple dozens of petabytes with a P, right? Petabytes from local data centers into the cloud, because there was that much data, and they had like 3 data centers spread out along the East Coast, and they were maxed out. 3 data centers, hundreds of servers there, and they were spread out thin. They need to have more scalability, so we moved away from that local data center deployment. So that's the answer for this one. Why not stay in SSIS? What we want to have is this, right? This is what we want to have. What is this? As you can see here, we have compute nodes, and you have storage systems that are connected through some networking, and they are coordinated. There is a coordination going on in here, listening to user requests, having the user request accepted, and then dispatched to nodes that will process that particular query. So if someone is asking for a sum of sales of the past 30 years and going through, like I said, 100 terabytes of data, this guy gets that query and allocates a few nodes, as many nodes as needed, to go over the storage system and split that storage system. They will make the decision about splitting that storage system in a way that each node will work with a slice of that 100 terabytes of data. And when they're finished with their slice of computing, they will combine the final result from each individual node and send it back to the client. This is scalability, computing scalability for compute, right? And one thing to keep in mind here, it's very, very important, is always when you are doing cloud computing, it's kind of that on-premise too, but we don't pay much attention to that. But when we are in cloud computing, it's always important to have that mindset that I have compute in one side and data in the other side. They are disconnected, and they should be able to scale up and down individually as needed. So like I gave an example, right? Someone asked or executed a query that would go over 100 terabytes. And I may have this 100 terabytes in here. But somebody else could come in here and say, you know what, I just want the sum of a particular month. That would be a couple of gigabytes, perhaps. So this should be smart enough to say, okay, for that query, half a node would do it. So I will run that particular query on half a node or just one node or just a couple nodes, and then work with just that particular data, perhaps not even splitting the data among nodes and running, because it's a smaller scale query, right? So it's always important when you do cloud computing to understand that data and compute are two distinct resources, and they must be deployed individually, connect together, and they must be able to scale up and down also individually as needed, right? That's very important, very mandatory, important criteria. If you are in the market, if you've been working with SQL Server for a while, and you have done SQL Data Warehouse before, you have seen this. Before Azure, right? You have seen this. This particular picture here, let me see here. Let me see. I think I need to get my zooming thing going. So let me get me back in here. Let me zoom into this. I'm not sure if you have seen this diagram before. I made sure to put here on the slide deck so it can kind of help us reminding about this particular design before Azure. This is an on-premise design. And SQL Server, when you buy a SQL Server license, when a company buys a SQL Server license, it can be like a developer license that's free, so you don't buy. It's a developer license. It can be a web license, can be a web license. It can be a standard license. It can be enterprise license. And there was this one here. I didn't put the name in there, but there was this one here called the PDW, Parallel Data Warehousing SQL deployment. This was a very expensive one. Was above 7 digits figure, right? So it's like a million and a half, depending when you get started and how much hardware you're gonna have on top of this one here. And the idea of this one here is to implement a sort of parallel data warehousing. This was actually to implement parallelism in terms of compute. If you look into this diagram here, you see that oh, let me change the color here, put blue or yellow. Perhaps yellow is better. There we go. Let's see. No, yellow is not that good. So let's do blue. Whoops. And get my square going on. There we go. So if you see this this array here, this particular array, this is hardware, right? It would be bare metal machines because we want to have the highest performance possible. And what is installed in this array of servers here is a SQL Server, right? These database servers, these are SQL servers. This is SQL Server in a distributed fashion. So Microsoft already had, not just Microsoft, but there are other vendors like Oracle and some other ones, IBM, they had this kind of installation here for on-premise way back in the 2000s, right? Way back in the 2000s. And attached to this array of servers, we have the array of storage. So as I mentioned before, what I'm showing you in the cloud, what I showed in the previous slide, is nothing new. It's just a new implementation of a traditional design. Compute in one array, storage in the other array up here, and they could scale up and down individually as needed. So that approach was already there. What I need you to pay attention here, and you need to call your attention to, is that this is SQL Server, right? This thing here is SQL Server, is not SSIS. If you look into here, you see that SSIS would be sending a workload to SQL Server through a client drive or something. So SSIS is a client of SQL Server in this particular on-premise design, and the control nodes will send the query that's coming from SSIS and process it in SQL Server, and hitting the particular slices of data from the storage nodes as needed, right? And then the final result goes back to SSIS. So even in an on-premise platform in parallel data warehouse design, SSIS was not scalable the way we're talking about. SQL Server was, but SSIS was not. So all of this first 20 minutes of introduction and kind of a convincing to make sure that you understand that this is the way to go, right? We cannot stay in SSIS, period. All right, so how do we move along? How do we get how we get to do data transformations and data integrations, as we call it today, in the cloud? Well, assuming that you are an SSIS SQL developer, right? You're SSIS professional. I want to connect what you already know about SSIS to what's in there in the cloud and how we can bridge the tasks you do with Microsoft offering, right, for data transformation, which is twofolded. I'll show you in the portal in a second. So in SSIS, and actually I do have here a VM that I created for this presentation. Let me get the VM up here. Yeah, we are here. So if I go, there we go. So this name here, Data Toboggan 2022, like Jim mentioned in the introduction, I usually present on that conference. Is a Europe-based European, I think it's in UK, right? The folks are from UK. They put this conference together there, and there's one coming in a couple of weeks, next Saturday, not this one, but the next one. And I'll be presenting that in Synapse again. So this one was from last year. I presented this particular session to them last year. So I decided to use the same infrastructure that I have for them, for you here, guys. So with them, I have here an infrastructure where I have a SQL Server virtual machine running SSIS. So let's get to that SQL Server virtual machine here, just quick. Get this thing here a little bigger at my end, and then I'm also going to get a little bigger at your end so you can read along with me. So let's zoom in here a little bit. There we go. Yeah, so I have this virtual machine there running SQL Server on-premise, and I do have an SSIS package there, one of those Microsoft sample ones. So I'm going to connect to that virtual machine, use Bastion, which is a resource in Azure, to connect to a virtual machine that's also running in Azure without exposing a public IP address. It's just through the web browser, through a routing that exists inside the VNet and the virtual machine. So kind of super secure. I don't have to worry about firewalls and these things when I do Bastion. Oops, back here. And here we go. Minimize this one here. And there we go. Here we have an SSIS package. So in, again, this is just an example, nothing very elaborated in here. It's just some elements that I want to bridge over to our environment in Azure. So when you go into our SSIS package, we know that we have over here a control flow tab, and we have over here a data flow tab. What happens in these tabs? Well, control flow, using today's terminology, is usually for orchestration, right? You want to define the flow and the criteria for the package to run end to end, and finish the processing of whatever we want the package to do. So control flow is not about transforming data. It's just about what the steps to get the data transformed. The actual data transformation, when we do joins in between data sources, when we calculate things that will be written into the target data destination, happens here on the data flow, right? This is the other side here in the data flow. And it's giving me an error here because when I sped up my environment this morning, I noticed that SQL Server, the SQL Server that I have in this virtual machine is SQL Server 2022, but it was the preview edition on 2022. It came in GA a couple months ago, back in November. And the engine here is not starting anymore. It's like, hey, your evaluation period is over, man. You gotta get the final product now. So I didn't have time to do the upgrade, so the SQL is not running. But the package is here. We can still work with the package. All right, so and here on the data flow is where the data is actually processed and transformed, right? We add extra information to it to do calculations, whatever we want to do, and you write to destination. So what is it here? So this is what we have in here, right? We have the control flow engine and you have the data flow engine. Now, it's interesting because some of the names we use in SSIS will show up in a cloud platform. And they may have the same meaning, they may not have the same meaning. So here, for instance, there is this name. This is a diagram I got from Microsoft documentation and SSIS, and also Microsoft official curriculum for SSIS training. So they call what happens in the data flow, they call it a pipeline. So this thing here in the data flow, this guy from here to here, this is connecting to a source, this is connecting to a destination, and this little arrow here is my pipeline, is the data flowing, right? The data flowing from here to here. And if I want to do extra transformation to the data, I have my options here on the toolbox to do the transformations into data down here. Got other transforms here for Azure, we'll do some stuff in Azure there. So I got other transforms in here. So this is what we do. The first step on SSIS to make sure we are on the same page. So how does that transfer to Azure when you go to Azure? Well, before we get there, one more thing. Down here at the bottom of this, we also have these guys here, right? The connection managers. So the connection managers, they are like connection strings, right? They use a particular technology to connect to a data source or data destination. It could be ODBC, it could be .NET data providers, could be JDBC, can be a few technologies in there. So we do have three things: the control flow, the data flow that we mostly focus on, but we also have the connection managers. And the connection, some people, if you're following a script, more likely you're going to come here and add a connection first and then do your data flows. Or as you do your data flows, you can come here and add a new connection from here, right, using the connection manager. So same stuff about the connection manager. When we go to Azure, and let me go back here to Azure, and that is something else I was working on. Let me get out of there and get back in here. Nope, sorry. Wrong resource group. Where is my data toolbox? Down here. This is an Azure subscription that Microsoft gives to MVPs and trainers, so we can do this presentation to you. I'm not spending any of my money on this one here. They give me credits and I do it here. So yeah, so when I go here to this resource group that I made for data toboggan, I do have in here, so this is the virtual machine, and pretty much all of the other resources that are in here are related to the virtual machine. They have the disks there for the database and the whole stuff in there. And down here, if you can see it here, down here, I have my Synapse. It's actually here, kind of behind me here. I have my Synapse resource. So Microsoft Synapse is an environment. It's not one service, it's multiple services. It's kind of an umbrella name, a kind of environment in Azure made by Microsoft. So it is a Microsoft service because in Azure, although Azure is a Microsoft cloud service, Azure hosts, and Microsoft Azure hosts services from other vendors. So inside Azure, you have Oracle, that's from Oracle, but runs in Azure. You have a bunch of Cisco virtual devices. They are from Cisco, but they're running in Azure. And you have, a bunch of other Linux, Red Hat, SUSE. You have a lot of vendors having their products hosted and running in Azure. Synapse, Microsoft Synapse here behind me. Synapse is a Microsoft developed service, so it's from Microsoft. And what it does, like I said, is an umbrella. It gets together, it stitches together a bunch of services that we usually use to do data transformations and to, to process massive amount of data, ingest and store and process and deliver reports on massive amount of data in the cloud. So this is Microsoft offering for that. There are other offerings. You probably have heard of Databricks. So Databricks is another example of a third-party company that has their product hosted in Azure. So before it was Synapse, there was Databricks. So Databricks came way first, a couple of years before Synapse was around. And Databricks kind of does a lot of things that Synapse will do, but we're going to leave Databricks for another session, to another day, for two reasons. One, because Databricks is another product. Another one is because it doesn't have the graphical visual interface that we're going to see here. Before there was Synapse, there is also this other product from Microsoft called Azure Pipelines. Not that pipeline, sorry. Data Fabric. Where is it? It never shows when you're looking for the thing, right? Let me see. Databricks there. Data Fabric is for some reason not showing. Data. Oh, there you go. Data Factory, not Fabric. I messed up the name. Data Factory. So there is this other service in Azure called Data Factory. And Data Factory is to do what, the same thing, is to do what SSIS does, is to do data transformations. So before there was Synapse, there was Data Factory. And here it can be a little confusing, right? Because you have two services from the same vendor from Microsoft, kind of doing the same thing, right? Data Factory is for data integration, data transformation, and Synapse does a lot of other things, but within Synapse, we also find a service to do data transformation, data integration. So which one should I use? Well, it's really up to you. But in most of my projects, I usually design for Synapse and the transformation pipelines inside Synapse because of the integration and to get to the final product faster than using individual services and then stitching them together. In Synapse, they're all already stitched together. So I don't have to worry about those, right? About that extra work of security and giving permissions and things like that. Bottom line is most of the things I'm going to demo here for you now, they are available here in Data Factory too. You could consider Data Factory. There are very edge cases when Data Factory can do one thing that Synapse cannot do, and the other way around, right? So let's focus on Synapse. Let's get back there, get back in here. To get to Synapse, once you have created the Synapse service, once you have provisioned your Synapse service, there is this link here to get to the Synapse workspace. And that's another thing in Azure. You have the portal where you manage the service. It's like your system administration perspective. And you have the workbench where you really work with the service. It's called the workspace. It would be our SSMS, right, for Synapse. So if you click on this link here, or if you share this particular workspace URL here to the people who have granted permission to, they will be able to go and land on the workspace that already got in here. So here in the workspace, just for your orientation, in case you want to try this later, right, on your own time, like I said, Synapse is a collection of services together. So you do have data services going on in here where you have the data lake that you're going to work with the data from if you are using the lake elements. And here I have a few data elements going on here. So I have my lake. Let's still have data here. Let's see. No, there is nothing in there, but we're going to connect to this lake here in a few. So I do have a lake. I have a container in there. I could connect to other lakes and have them here. I could connect to SQL servers in the cloud or on-premise and have them listed in here. Here is where my scripts and where you're going to see some of the elements I'm going to demo here for you. And this is where we find our bridge into Synapse from SSIS. What SSIS does, you will be able to do from here, from the integration pipelines. So data transformation, ETL or ELT, we have two elements to it now, right? No ETL or ELT. In big data approach and data lake approach and lake house approach, we see this nomenclature very popular nowadays called integrate. We got to get the data together, want to integrate the data. It's kind of the same idea of data transformation. So this is where you're going to find it. And again, see the idea of pipeline. So this is kind of a pipe in here. The icon here is the idea of a pipe. So the idea of pipelines. And this is where we're going to live. So if I go here and create a new pipeline on integrate, what I'm doing is creating what would be my SSIS package. So my package would be a pipeline. Again, if I go back to this diagram here, the keyword pipeline in here is the data flowing from one source through transformations all the way to the destination, right? In SSIS, in Synapse, the idea of the name of a pipeline is not related to that. The name of the pipeline would be a hybrid in between the control flow and some other elements. So my pipeline here, it's actually my control flow. And just to make the bridge in terms of technology, I'm going to call this thing here control flow. My control flow. And I'm going to collapse these things just to have more space here on the, well, yeah, I can minimize this for now. Just to have more space here. As you can see, the whole environment is browse-based. So it's very important for portability, right? You can do these things on a Windows, on a Mac. SSIS, you need Visual Studio. Visual Studio works on Windows, so we have to have a Windows workstation. But here you can do from any machine, right? From Linux, using Opera, any supported browser, and you can get it from here. But keep in mind that you are in a browser. So if I close my browser, whatever I'm doing here is lost. So I have to publish what I do from time to time to push what I've done here in the browser to be saved in the cloud storage, which we can discuss some other day. So this is my control flow right there. If I go back to my virtual machine and go back here to the control flow, I see here the tasks that exist in the control flow. So I can do like an FTP task, to download or upload a file through an FTP protocol. Let me zoom in here so we can all see that, right? These are tasks I could do and orchestrate into my control flow pane. The same thing goes in Synapse transformation pipelines. But here, instead of being called activities, right, like they have in Visual Studio, I'm sorry, instead of being called this, actually, what's the name for these things? I don't know the name of this. These guys here, they're named activities in Synapse. So if you want to do like a data movement, right, if you want to move data from one source to one destination without transforming the data, is just dumping the data from a source to a destination, you can come here, for instance, in the move and transform and have a copy data. So copy data is kind of a task to get data from one place, from source to destination. There we go. You can get it like this. There are multiple other options in here, right? If you want to, let's browse around here to see. So Data Explorer is another service that exists inside Synapse. So if I use Data Explorer, there is an activity here to orchestrate activities inside Data Explorer. If I want to use or invoke an Azure function, it's time to do some processing outside this into a code that was deployed to an Azure function web app. So I can call it from here. So the list of elements in here are kind of a little different. But here they are, right? These are my options. You know, if I have Databricks running outside my environment and I want to run a notebook, Databricks notebook or a Python script on a Databricks cluster, I can do it from here, and off we go, right? There are multiple elements in here. I don't have in my SSIS packaging here in this particular example, but we do have these loop containers, right? Or the for each loop containers, right? For when you're working with an array, for instance. And the same we have here. So you have iterations and conditionals. So I can do like a loop, and I can get this guy here and define a loop in between, define a loop based on a data set or a web call that I get to source. Like I may get here a web call, and I define this web call here to go to a particular REST API endpoint and make a call on the API there, and it returns to me an array of things I'm supposed to process, and I can get that array out to for each to loop through that array, each element of that array in parallel. So, all these activities that are in there. And exactly like control flow in SSIS, I do have those arrows, right? Like if after I copy this data here, I want you to execute this loop, right? If the copy operation succeeded. Now, if the copy operation failed, let me get just a placeholder here. I'm gonna get something here just as a placeholder. If the copy activity failed, I want you to execute this guy here, right? So you do have the same idea of the data flow. What I find funny here of a control flow, sorry, of a control flow. What I find funny here is that we in SSIS usually the flow goes top down. In DTS before SSIS it was left to right. And now in integration services, back left to right. So the orientation kind of changed a little. Found that really funny. I see John here, question for later. What is the best practice to move over 300 SSIS packages to Synapse? Is there a way to automate that? All right, so what I'm going through here, John, is not move SSIS packages, right? We are going to the idea here is to rewrite them so they can scale using cloud technologies. If what you want to do is a lift and shift, like your question implies, right? You have those SSIS packages on-premise, and you want to run those SSIS packages in the cloud, you can come in here, and there is an option in here for SSIS. You see, execute SSIS package. So you do have this particular activity that you can orchestrate. You can get your package into a storage place, into a storage account, and defining here where to find your SSIS package and which compute profile for virtual machine to run your package. So you can just lift and shift and orchestrate the execution of your packages from here. But when you do this, you are not scaling up, right? You're doing lift and shift, and you're going to still be restricted by the compute power that's given to a package when it executes, and the compute power goes in here, right? In SSIS integration runtime. It is a fast, quick fix, right? You get something from on-premise to the cloud. There are considerations in terms of network connectivity and these things, but you're not upscaling your compute capacities. So I want to make that clear, all right? So that's how you go by it. Yeah, sorry, I meant rewrite. No, so if you're into rewrite, there is no automated translator from SSIS to this or Data Factory or Databricks. As far as I know, that doesn't exist. If some company comes with that, that would be interesting. But as far as I know, that doesn't exist. We do rewrite the whole thing because there are some extra elements to it. So that is that. Okay, cool. What else? So this is about orchestration. Let me go back here to the slide deck. We're approaching our time. We are just in time in here. So in SSIS, we do have this idea of project. And a project boxes together a collection of packages and define when one package executes other when to execute the package and move from to the next package. And packages can also call packages. In order to have a project, you do need to have an SSS catalog in SQL Server. In Synapse, in transformation pipelines, the idea here is just having pipelines calling pipelines. So if I go back in here, see I created that control flow in here, I can add another pipeline. And here in this pipeline, I can have pipeline. See, execute a pipeline. And just for the sake of illustration, I'm going to call this guy here SSS project, just for the sake of making the bridge. And here from this execution pipeline, I'm calling only what would be a SSS package, right? A representation of the package. And that my control flow that I have created there before, see, it's right here. So I could call that control flow here. And once that is done, I could go ahead and execute yet another pipeline. And the other pipeline would be a second would-be package, right? So the same structure you have in SSS that, a project that calls pipeline in Synapse. It's just pipelines, and they can do either the regular tasks or just coordinating the processing of other pipelines, right? And you create a hierarchy in between your pipelines. So the same thing we have here happens there. I already showed this to you, right? So when you're doing orchestration, you can define what's the next step if a particular activity fails. So in SSIS, it's actually called task, right? So we have tasks in SSIS, and we have activities in Synapse pipelines. So you can define when a particular activity runs, after it runs, it fails, or if it succeeds, or regardless, whatever happened, you can define the next step. I already show you that here to you. It's pretty similar, right? We have the two things in here, right? The succeeded, fail, or whatever case. Jeff got another question here. In my SSS package, I have a script task. Is there a similar activity in Synapse, or do I have to convert the code into some other Azure object to be called? So your script task, that's an excellent question, Jeff. Your script task is a .NET task, right? KBAVB script task I think is still there. It's kind of being deprecated a few years ago, but you could have like a C# code and do your script elements in there. Here in the transformation pipelines, you don't have an option for C#. You cannot do C# thing, but you do have an option here for a script. And if you go here into the script, the option you have in here is to make a call to some other compute service that will run your script. So here, for instance, I could have a SQL Server dedicated SQL pool in my Synapse, and I could ask the SQL Server SQL pool to run a store procedure or to run a transformation code that I have in there. So I could dispatch this to my SQL Server, right, when I do my script. If I have other services connecting there, they could be sent to someone else. So the bottom line is, to run a script, you need compute. And your compute will not be in integration service unless if you do notebook. Unless if you do a notebook. So to your question, Jeff, if you want to write code, script code for transformations in pipeline and have them run in the pipeline itself, not dispatch to another compute element, you're going to write a notebook. And here's where you write your notebooks. So if you go here into develop and create a notebook, you can have your notebook here. My script notebook. And you can define which language you want to code in your notebook. Python is usually, Python PySpark is usually the most popular one. C# still, it is an option here. So you can come and write some C# code using the libraries that are available there for you. And when you go back to your element here in the settings, you will be able to select my script notebook. You'll be able to select your notebook that's in there. So that's how you would run a script hosted within the pipeline itself if it's not a crazy heavy script. Otherwise, you want to dispatch that to an Azure function, to another Spark node using a notebook there, or some other resource, or Databricks, or whatever you want to do. All right, let's wrap it up. So, okay, that was another one. Oh, yes. So this is what I explained, right? Within packages and across packages. Across packages would be across pipelines. And these are the elements we find around in SSIS. And this is what we see here in the integration pipeline. If I go back to the virtual machine, I did highlight the connection manager. So what's the deal about the connection manager? Now, and what about the control flow? How do I get to these guys? So what would be your connection manager in SSIS? It's what they call linked services. So if I go here into the management tab of Synapse, I will see here my linked services. And there is a difference here in between the linked service or the connectivity, data source and destination connectivity in Synapse. There's a difference in between here in Synapse and SSIS. In SSIS, you have like the connection string and the driver as one element in the connection manager. In here, we have two distinct elements. One is the connection, the linked service is the actual processing of the connection. And the other one is the data set, is what you expect to receive from your connection from the linked service. So for instance, if I go back here to my transformation, and here in my transformation, so far I have only done orchestration. What about if I want to do the data flow, the actual data transformation? So for the data transformation, what you have this thing here called data flow. So data flow is my data flow. It's the same name. Cool. My data flow is my data flow. What would be my data flow in SSIS? And data flows, they are elements in itself, and this is just a reference to a data flow that you would create. I don't have any, so I have to create one right now. I'm going to go ahead and create one in here. So here's the data flow. There we go. I need to start adding a source, where I'm going to read the data from, exactly like the data flow we have in SSIS. So I got it here in the data source. And when I get to the data source, what's going to ask me about, there are some settings in here, and there are way more options than we have in SSIS. We got to go into the details of that some other day, how you're going to bring the data into memory, because this runs on top of a Spark engine. So the compute is actually Spark, it's not SQL. And when you do Spark, everything runs in memory. So it's going to bring the data set into memory. And here are the options of how you're going to bring that data set. But the most important here is this, the source options. Yeah, here are the source options. So when I get into the source options, I need to point who my data set is. Remember, two things, data set and linked service to get to the source. So I need a data set. I don't have one. Let's create one. Let's say I'm reading from SQL. I'm going to read a data set from SQL. So remember, I'm not connecting to SQL here. I'm going to point out to a record set, like a result of a select or invoking a stored procedure. I'm going to call something in SQL that will give me a data set, a data frame, a result set, a table to work in my transformation. So I'm connecting to SQL. And the next step is like, great, you're connecting to SQL. Which SQL? Now the linked service I just showed you, right? So here in linked service, I'm going to click on this guy, and I'm going to establish my connection to a SQL Server box. And I think that's the point where I will have to let me see. Let me see if I can get one here. Let's see if this guy is up. Select the database. There's a master database here. Let's try this. Hopefully this will do. Create. So there we go. I got a connection to a SQL server. And here again, I can connect to the connection failed. So if the connection succeeded, they could have a table name here, selecting it, or just define an element from the server, like a store procedure. I can call store procedure from there, whatever I want to do. So in here, let's see, no import schema. Let's do this by name, and let's call this thing here DBO sum table. Nothing of this exists, but at least the step will be completed. So let's click on OK here. Nope, don't import the schema. Get an OK here again. So there we go. Now in my transformation, in my data flow, I have a source that is connecting, that's expecting a particular result set, and from a particular server. And from here, I can start doing the tasks that we would do on a data flow. Like if I want to do a union, a join with all the source that I'm going to add in here, if I want to add surrogate keys, if I do some sort of aggregations, pivoting, all my data transformations that are allowed in here to generate a new result, I would add them up in here. And at the very end, I would write this thing to some place. And the funny thing is, writing to a destination in SSIS is actually called sync. Sometimes I feel like a plumber because it feels like we ran out of technical terminology. We are not using databases, we are using a data lake. And in the lake, we are syncing elements in the lake. You are punching data there. So some of these technical terms, they became a little funny. I kind of love them, to be honest. I have fun with them. And so this is writing to destination, right? So this is my data source, and this is writing to destination. And here goes the same thing. If I'm writing to a destination, I'm writing to what would be a table or a file of some format. So I have to come here and once again select a data set to write to. And of course, it should not be, usually it's not the same of the data source. I'm going to create a new data set in there. And if I go here to, because I already created a linked service, if I go here, I will see that linked service I just created over here. See, it's already here. And the data sets are defined here into the pipelines. Data sets will show up in here. All right, so that's kind of a brief introduction of how you see things in SSIS and how they are very similar to things. How similar things are in Synapse when you do that bridge, that comparison. It's more involving, it's more complex. There are language barriers, like C# is an option there, but it's not the most popular one. Python tends to be the most popular one. We also have different ways of implementing variables and parameterization. So that goes deeper than what we could do in an hour. But as you can see, the road is not that rough, right? When I was down in Hawaii here, I made it to Piahi, and Piahi had a really rough road. This is nothing close to what we see there in Piahi. This can easily be bridged over, and you can get well-versed in Synapse transformation pipelines in no time. So I hope that helped you to get a glimpse of how things work in SSIS. And let me see if there are any more questions here. John, if you are there, you're welcome to rejoin. Question, if time at end, what is the best way to send email from Synapse pipelines for errors and other information? So to send messages out, to send emails out, you have a few options. You can report an error. Usually when you run a compute element in the cloud, is usually unattended. So you want to record that error in a log so we can analyze those logs together. And when you report that, Azure collects that error. You see, there is a log going to an error, and you can have like a logic app or an event grid monitoring those things and asynchronously monitor those things and sending emails out as needed, right? So that's one way. If you want to send straight from a script in the pipeline, you can also do that, John, right? You can also do that. So you have, you have libraries you can send from C# code. You can call an Azure function that does something else and send an email out. So there are multiple options, right? There, depending on how you want to manage that and track that. Christina here. In SSIS, most API-related GET posts, we have to use script task C#. How about in well, Azure here is an umbrella name, right, Christina? We're talking specifically about the transformation pipelines in Synapse. So I'm gonna fix it there. So how about Synapse? Any API tasks in the Synapse toolbox without writing C# code? The answer is yes. I kind of a glimpse over it. So let me go back here to this guy and to SSIS, which is here. And if I go back to my control flow, right, to a pipeline, here I have a web task. Here's my web task. And here in the web task, I have a URL to call, and I can choose get or post. And if there are authentication, what is the key for authentication, and the payload can be added in the headers and so on. So no code call right there. All right, Christina, I hope that answers your question. They've missed first half. We'll be sharing the recording